I want to continue to talk about the theme of how to make enclosures for electronics products. As I have explained to you earlier, the simplest thing is something which you would like to probably make in your lab, and then after having tried the circuit you want to put it in an enclosure such that it can be presented to the public. This I will say is a little better than hobby or what do you say, lab exercise type of thing. There your idea is you have a concept and then you want to see if it works, and then minimum amount of protection you would like to see. If you lose wires also is not an issue. At the other extreme we have extremely complicated and what do you call potentially life threatening situations for which products are designed. One of the thing is, imagine weaponry that is used in a war. So there is nothing like it is alright if it fails, we will leave it in orbit. It is even more dangerous than a aerospace application. Or imagine something which goes inside the brain here and inside, or inside the heart here, some new pumps or something which will have to inject things through the screen and all that. That is really something you cannot afford to have a failure there. A failure is the end of the world for everybody. Now let me go back to yesterday's thing and then I will start with the PPT. See, I will show you a few examples from mechanical enclosures just for a roundup of what we did yesterday. At one point here we have very important thing about the main function of the product is its functionality. You have seen it, no? Very important is number one thing is about functionality. If something does not work, obviously nobody will buy it. It is not like an art piece where appearance or the reactions it evokes in the user are the important thing. In this case functionality is how it works. It has to work. A light has to give light, and then if it is a watch has to show time, you have no choice, and show correct time. We can have added attractions like that. No, watch these days does so many other things. Basic functionality for an amplifier is obviously amplification with certain specifications. And then something which is equally important is probably the ergonomic aspects of it. Okay. The ergonomic aspects of it is that it should be convenient to use, easy to use, and it should not deter the person from trying to touch the object. If something looks threatening, it is unlikely that you will touch it. It should be user friendly. Once upon a time they used to take products and hide them behind on a glass shelf. But the things have changed now. They do not hide anything behind a glass shelf. If you go to any shop, including something which sells very costly DSLR cameras, they want you to experience it. They will give you a camera in your hand, and part of the success of all the new retail is that it has almost a word called retail therapy has been coined. You need to go there. If you are a DSLR fan, you go to a shop which sells cameras, handle all the cameras, maybe try what you call the zoom, and then maybe try everything and see how it feels and so on. Same way, if you were to go to a specs shop, I think I gave you this example already, you will probably try on the frame, have a look at yourself in the mirror. The moment you look at it, the person will know obviously the ergonomics is right. Okay. Here you will notice that the ease of use, how well you use it is very important, and various things, especially something which is related to the anthropometric data. That is, what does the population normally use? It is very important. So we have this ergonomics where anthropometry also is included, and then quite an important thing is the aesthetic appeal of the product. Unless the product appeals to the person, nobody will buy it. That is the reason why even if you are to take an Apple computer, you will see the Apple logo at the back of it all lighted up. If you close it, it looks upside down, but obviously everybody wants it that way. You will be surprised to see that we often select even monitors, computers, everything, no, based on how inviting they are. If they are more inviting, they are more what you call useful, and something which is beautiful is probably is already, you have a positive attitude to it, you will work carefully about it. And then something which we should never forget is this marketability. Again, marketing is not selling. All these 4 items are not in any way related, saying you cannot have over the wall approach. That is, somebody makes a functional product and then after that he says kindly attach ergonomics to it, and later on sort of spruce it up, make it better and make it there, and finally dump it in the market thing. Any of the sequential appeals or what is called the over the wall approach may or may not work in all the times. Marketing is probably a good starting point, but then it does not mean here are only people who can define what the product is. Other extreme is they can probably go somewhere else. Now we know, we have the dragon. They can go to the what you call birthplace of the dragon and then buy it and try to sell it to us. Then you will notice that it is not easy. Now I will go on to the next slide, which if you remember we started about what is the core product, the functionality and all comes here, core benefit or services like that. Then obviously tangible attributes, that is the usability, functionality, durability, quality, performance, features, form. And the next level comes to the intangible, saying opinion based, saying it is a good product, we buy it. And then something which is augmented about installation, delivery, after sales, branding, finance and warranty. A lot of products are sold these days not just because they are good, they are because they are affordable. We have a financing option which will make it sure, because of this financing, you can buy things always on installments, and you can buy things which you can afford, you can decide. And then of course branding gives you an image which says yes, this is quality, absolutely. Otherwise you wouldn't have had branded bags, branded jeans, and now even branded commodities like we have branded salt, though sugar is not branded yet, so I can just imagine it. Then something related to how well it is installed and so on. Now coming back, if you remember, we have the 4 things we have talked about, saying maintainability, ID and manufacturability. Then we wanted environmental, thermal and interconnection. This is actually the core of my course. Now I will get back to typically something you are likely to find in your house. This is a Nintendo Wii. Nothing. If you see carefully, this Nintendo Wii is nothing but it is a drive. It is a disk drive in which you put a CD inside and then it is supposed to work. But then how does it work so well? You see here, if you see carefully, there are so many items here. So this is the core part of it, which this part of it is the drive part. And then you have at the back a tremendous amount of work which goes on at the back. We come to one corner. Connections, you have an interconnection here, you have one more here, and then there is something here very funny. It is probably an antenna which will connect it from the external world. And very important part of it is you have all these. You see, this part of it is made in a molded, mass produced item. Okay. Somehow in a very magical way it is married to same mass produced metal parts. So you have here products which the load bearing part as of now cannot be replaced with plastic. Plastic is good up to a certain point, especially in very thin sections. If you are to take a mobile phone or if you are to take a digital DSLR camera, one of the first things you will notice is the core part of it is probably made from a special alloy, usually a magnesium silicon aluminum alloy. A magnesium silicon aluminum alloy can be made into small portions, and then special injection techniques are there by which can make something strong. Now going back to my slide, a little closer thing, you will notice that it has several very interesting things like that. You can open it, you have seen that this part opens up nicely, and then you have here some contacts to which make sure that RF isolation is done, and then you see very nice beautiful way of interconnection from one layer to the other is there. And then this one, now we got it. No, it's an antenna. It what you call communicates without any of these cables directly like that. Then you have seen this, we have a nice beautiful aluminum devil here, otherwise known as the heat sink. A heat sink is actually a misnomer. Strictly speaking, it is not just a heat sink as such. Okay, it is not just a heat sink. I will just go back a little and see if I can just locate it. Okay, it's, I do not have a close up view about it. The idea of a heat sink is it just a heat spreader. The beauty of it is this is a heat spreader, and then on the other end now you have a small what you call fan there. What this heat spreader does is it will take heat from any of the hot points, and then it will try to take it into another place. And then one interesting thing you will notice is it is not black color. Heat sinks need not be black. In fact, they have found out that heat sinks probably should not be black, because black is a very good radiator as well as it will even absorb heat. It depends on the temperature difference. Normally ambient temperature inside an equipment maximum maybe 90, 80 and so on, and the devices and all that may or may not be about that. But just next to this, imagine if you have a really hot component, let us say there is a resistor which goes above 110 degrees, that will be passing on heat to the black heat sink and not the other way. And most of the time heat sinks, the mode of heat transfer is convection. Because of the convection does not need on color. So you will notice that a heat sink is one of the unavoidable portions of this. And now further, if you go inside, you see here we have a printed wiring board. So this printed wiring board, contrary to normal lab exercises, is rarely a rectangular shape. I am not being what you call, I have no criticism about it. As a lab exercise, it is worth trying to lay out a PCB taking the four corners of the screen, because you can do things and all. You can learn how to lay out a PCB, how to make a schematic capture, how to make a rat nest, and how to do routing, and then how to also what you call space all the components properly. That is, you make sure that things fit naturally in all the places, and then you can often locate the, see in one edge here, in one edge here they have made the connector here, and then you see here it is at an angle like this, because the connector is folded and taken off there somewhere, and then you have something, and then you have most important, you have the fastening screws you see here. So two or three things you will notice about it is, fasteners need not be located at the four corners, and very rarely in a professional equipment the printed wiring board is a rectangular thing. Generally it has all these fancy shapes, but for your, in case you are a serious hobbyist or in case you are a learner for the first time, no harm in making it, because next round any of these product designs requires two rounds. The first round where you prove your circuitry and your technology and all that. At the second round you need to now make sure that the whole thing can be enclosed properly, and then once you run the thing, maybe on the third iteration you have a professional product which you can now try to see how best you can do with it. I will move on to the next slide. Very interesting thing, and even this so called sheet metal is no longer in a sheet form on a level flat shape. It is embossed everywhere. Embossing has two advantages. One of the advantages is you can maintain the level. You can make something at a higher level, lower level. You see here this portion of it is at a higher level. This portion of it is at a lower level. Then there is a small thing here, probably it is part of the where you push some other thing, and then all these various fastening devices, even these things have been kept nicely depressed so that they have their proper function. And then if you see here, even depending on the method of manufacture and depending on the quantity of manufacture, it is possible for us to make very complicated specific to the product enclosure. So, typically what is just not very different from a CD drive as used in a V or anything which is based on a CD, this thing, they have spent such a lot of effort. It obviously does not come the first time. It is in fact probably it is second or third attempt like this. So, you have here beautiful perforations here to make sure that whatever function they want, probably it needs a little bit of external cooling. So, I will just allow you to take a look at these things. I will just point out various features, you have a look at it. You have noticed everything seems to have a special thing, including a few things they have even either marked or directly stamped orientations of thing, and then you have fastening devices, and then you have a small step here. They have made a small notch and one thickness they have taken it inside. I do not know, unless you see the whole thing, we can't make out at this stage what is it. Now, if you spread all the parts and keep it here, you will notice that it is good, it is beyond belief. You have that beautiful cover in one place, and then you have the main PCB, and then you have here that heatsink business which I was talking about, or a heat spreader, and then you have the cover which you have seen, and then it also seems to have a slightly different color. It is not a lighting. They do something to make sure that this thing does not get corroded. That is where, as part of that environmental thing, if you remember the first slide, I drew a circle around, and then on the circle I have also showed you that how well it puts up with all the harsh environment is all included. The moment you put a fan and the moment you send air into it, you are exposing all the circuitry to the ambient. So, one of them is that it is corrosive not in as in acid, corrosive not as it in very harsh environment, even in a routine normal indoor environment. There is a tendency for any metal, especially mild steel, which continues to be the cheapest sheet metal, to corrode. So, to prevent corrosion, what they do is they try to plate it with some metal. Earlier it used to be cadmium, but in due course, last I think 25 years, cadmium has been restricted. So, right now most of them are made coated with tin. Either it is a pre-galvanized tinned sheet or anything, and then this yellow color is probably what is called bichromate passivation on top of it. That is, they take it and dip it in this thing. So, it will prevent another level of patch up and so on. And something which is very, this thing is, it will make all the finishes compatible. They look good, and there is no electromotive potential between the finishes which will cause degradation of this. So, next slide shows a little closer of some other product. I hope it all belongs to this only. You have come in several type of processors here, and then you have seen here the top, this is all obviously some heat sinking compound like thing. This heat sinking compound like this, what it does is it you can attach a heat spreader on top of it and then do everything, and then you see here, this is the most beautiful part. All of us know we love to hate it. This is the connector which is now the ubiquitous USB. Sometimes we associate USB with the pen drive. The pen drive is not the USB actually, it is the interface specs which are the USB. So, USB have type A, B, and then we also have mini and micro and what else will come, to the extent that most mobiles, this is the USB, this is also USB connection only, this has come here. You see here, next time take your mobile, have a look at it. I can't show it here properly. You see that there is a beautiful USB, I do not know, it is called probably it is a micro. So, we have this, And unexpectedly, even most of your cameras these days come with these different type of connectors like that. So, coming back to my slide here again, you will notice that I have the USB connectors here, and then you see here some very critical thing. This is, it is a clock crystal. Luckily, after the advent of the new electronics, you need not keep it in a very, what do you say, controlled environment for it. And then you see even the fasteners, no, you have here a beautiful earthing thing. So, there is a earthing plane somewhere hidden inside. You have all these things where the fasteners are fixed, and more important, you have seen that even small dots, and the way somebody has spent a lot of time to make that this is EMI and probably ESD proof. Once you properly make the whole thing, if you take it around a stray magnetic field, it is not like to make a difference. Not all the time it does. Sometime, next time you listen to a TV show or anything, no, you will hear some very funny noises. That is very peculiarly the transmitter antenna which is trying to locate from the cell tower saying I am here, sends very strong signals, and these are invariably picked up by these small, what do you call, microphones which we carry, whether it is electromagnetic or piezo or anything, no, invariably it will give the pet noise all the time trying to connect to the tower. So, life is not easy. And then a very simple, I am a dumb fellow with a smartphone. This has 5 to 6 antennas inside. It is a surprise to me how they have packed so many of the antennas to me. We all know the basic GSM GPRS system that is there. Then we have got a 3G and 4G, then we have got a near field communication, then I have a Bluetooth with it. Oh, then I do not know what all things are all fitted with this. Even the hearing aid I have, this hearing aid is left hearing aid and the right hearing aid are interconnected with the Bluetooth communication to make sure the phase, it is in phase. While you, especially young people who can easily hear things, it is natural, you will not think about it. If I were to wear a hearing aid, I have a part of bone conduction, part of air conduction like this. So, there is a small phase difference when the hearing aid processes it. So, all those things are built inside. That is why it is a little expensive hearing aid, which incidentally is the cheapest in the thing. It costs only 50,000, cheaper than lot of jewelry. Now, I will get back to the first very simple thing which probably you can do in a workshop. This is nothing, I just can't say. This is probably a box was made so that we can put any microprocessor based small PCB inside. It was part of a exercise meant for people who come to the workshop first time. The moment you have a concept, one of the things you will notice, if you have to just take this box as it is, this height is limited. This is probably, I will do in millimeters, you can convert it, probably 80 millimeters, not more than that. And similarly, if you remove for various effects, I remove 10 millimeters here, and then this length is probably around 180 millimeters, width is probably again one more, say 180 millimeters. You will notice that if I remove all this, there is not enough place for the front panel with which you play things. For easy purposes of easy layout, here a 3x4 matrix type of keyboard has been made, meaning it has 12 keys. So, normally 0 to 9 is sufficient for you, and another extra 2 keys are there which you would like to make. So, the obvious thing is that coupled with having to look at it when it is on a table, it has been made to be at an angle. As you said, is there a ergonomics or there is an anthropometric data for it? Not so much. It is a little about just look around, see other things which they have done and all that, because it is not as critical as an aircraft or a spacecraft where humans are to operate, or in the case of a submarine, which is very critical. It is in case you do a mistake, it is finished. This is generally more to accommodate the amount of space, and then if you keep it on a table and if you are sitting like me, you can reasonably see these things without glare. So, this is a starting point saying I have a raised small step here in which I have a front panel, and then I have a box in which an enclosure in which I can keep things. Now slowly we are getting into details. This being very standard this thing, and then you would like to probably make it standalone. I have tried to put the power supply here. So, invariably the power supply has a transformer. Most things inside, even if you take a big monitor or if you take a computer or anything, the voltages they work with are very small. Now with the new power thing we have 1.8 volts chips. Similarly, earlier we used to have 5 volts. So, if you take a power supply of a UPS of a what you call computer system unit, you will probably discover there are only a few of them, out of which 5 volts, 6 volts and 12 volts take a lot of current, and these days even little lower voltage also is available. But for purposes of illustrations, this course material was developed when a transformer and a series pass element, a regulator was required for maintaining the voltages inside. Now these hardware items, this will continue to stay, it still is there, okay. This will continue, we cannot get rid of it. This now is replaced by other things, okay. It is replaced by equally sophisticated heat producing and added to that something which is EMI inducing, meaning you have conducted and then you have also radiated or picked up from the ambient EMI and all that, just for us for the purposes of understanding. So, this part of it is a printed circuit board, okay. You need to put everything, and then we have a front panel, and then you see here, this is where we come to the important thing. This needs external exposure access. Understand? No, we have a what do you call a heatsink, and then heatsink, as I have explained to you in the earlier example, it needs convection. So, there are fins here just for rough aspect, I just put some fins here, and then it is a natural convection heat sink. So, in the case of a natural convection heat sink, you need to put things here. Now, if you want to fabricate the same thing in a sheet metal, one of the first things you need to do is to find out how well you can spread all the parts inside. Is there some way of making an optimization of the layout? At a first level, it makes a lot of sense to break it up into parts which are flat, because by definition sheet metal things are flat. Once they are flat, but you see here now we have a little problem here, is it very very much come to the close thing, very close to the edge, not easy to fabricate such things. So, you can combine all these things together and then try to make, see here, okay, I have combined the front panel with a little projection on the top and the little projection at the bottom, then the left and right sides have been combined with the bottom, and then in the top I have a what do you call a top cover, and then I can do proper perforations and all that and make sure that all these things fit inside. So, it is possible for me in one corner I can make perforations here, and then I can do something with the front panel, and then in due course it is not impossible for me to achieve a product which looks like this. But remember, the starting point was I have a concept in the product saying first of all this is required. So, when we talk about marketability, while engineering ensures that we can what do you call optimize a design, as such there is no simple formula saying what sells, not easy. I think first time when what do you call a thing like a digitizer and this pen came, people were not very happy about it, saying it is not easy, we can't make it. But in due course now we accept things. So, from a marketable product we come to something, and then eventually we make a product like this. As I said, this is about 20 years old. This one is a power meter.